I'll go out to the beginning. My name is Gillies. I am reader in computing here at Goldsmiths, and I co-lead with Sylvia, who is with us online, and I'm co-doing this talk with her. Actually, her name is not on my title slide. Apologies. And so, what the idea of this talk is that we're going to have a, we wanted to share with partners and students some of the, our thoughts on what the future of VR and immersive media will be in the next few years. And in particular, I thought a good way of looking at this is in terms of the opportunities for combining virtual reality and artificial intelligence, which is something I do a lot of, but in very quite particular ways. So it may be quite different ways of thinking about AI than have been mainstream in the past. So I'm going to start very quickly with what is VR and what is AI. Maybe many people will know this, but what I want to stress about VR, VR is a medium which involves immersion into another environment through a kind of hijacking of the senses. And one of the key features is that you're able to control your view of an environment through your own movements, particularly simply turning your head around, etc. But I wanted to stress a couple of things. First, that we look at it in terms of three main illusions: place illusions, which is the sense of being there in another place, this is simply an artifact of the fact that you can, of what I just said, that you can put on a headset and you can change your view of an environment just by turning your head. And that seems a very simple thing, but it's actually a very, very powerful part of the experience, going from being something that is mediated on screen, this simple relationship between your movement and your sensations turns it into something that feels like a real experience. And this is what's we say this reproduces the sensory motor contingencies that we have learnt or that exist in our real world. Or sensory motor contingencies really just means the relationship between how we move and what we see. So at the low level, that creates a place of being transferred somewhere else. At a slightly higher level, it's plausibility, the sense that what's happening in VR is real. It's not, this could be happening in the real world. And again, this is a slightly high level relationship between our actions and what goes on in the world. I'm getting a little bit of. Could anybody who's please mute? Sorry, I'm getting a bit of feedback here. It's the budget is. Can't even.
I can't hear anything, Marco.
Is that any better? Have you not been able to hear?
Yeah, that's fine. That's fine. I can hear you now.
Could you hear the talk up to now?
Yeah. It was just now when we were trying to mute everyone. Okay, I think we muted ourselves as well.
Okay. Right. Okay. And the third is embodiment illusion, which is the sense of having a body, which I won't talk about so much. But really, what I want to stress here is that VR is really about the relationship with what you do, and in particular your body movements and what happens in the world. It's not simply about a display; it's the interaction between how you move and your display. And so, your body movements is really important in creating this sense. So it's the sense that you're interacting as you do with a real environment, the real world environment, rather than in a mediated way through buttons, interfaces. VR experiences do have menus, etc. But really, the stuff feels most real when there isn't a menu there and you're simply picking an object up or waving at a person. So the other thing I want to talk about is what is AI. Again, many of you will be familiar, but I just want to specify that when I talk about AI, I really mean machine learning. And machine learning is a technique, you know, a really groundbreaking computer science technique. If you're not familiar with it, the best thing to think about is to think about the question of, you know, how would you program a computer to tell the difference between pictures of cats and pictures of dogs? I mean, this is an incredibly hard problem. I mean, you know, you can think of features of cats and dogs in terms of, you know, they have ears, but, you know, you know, different types of ears, different types of mouth, etc. But, you know, all we have is pixels. You know, how do we go from pixels to this is a cat, this is a dog? And so programming that kind of problem by hand is incredibly hard. In fact, nobody's really cracked it, you know, defining a set of rules. What machine learning does is instead shows a bunch of examples of cats and a bunch of examples of dogs. So lots of pictures of lots of cats, lots of pictures of lots of dogs, and uses these to learn an algorithm that can tell the difference between them. Now, what that basically means is that it builds a statistical model. So this is just, you know, it's not magic, it's just statistics. And this model takes an input, which could be a picture of a cat, and an output, which says this is a cat. And this is just a sort of mathematical model. You know, it is basically a bunch of statistics, and the parameters, the numbers in that statistics are defined using a set of examples through a learning algorithm. So that's, you know, that's all it is. I mean, machine learning sounds a really impressive thing, but it's really just statistics. And I just, for those of you who weren't familiar with the method, I thought hopefully that explains enough that we can show other stuff. So once we've got all this learning, we can just show a new example, and it tells you it's a dog. I'm going to talk about three main applications we have in VR and AR, content generation, embodied interaction, and virtual humans. And Sylvia will come in and talk a bit more about virtual humans. So I won't talk too much about content generation, but this is the idea that rather than people manually creating lots of environments, characters, objects within an environment, these are generated by algorithms. Now, this happens a lot in games. Minecraft is very famous. Procedural content generation, that's what it's called, based game. But increasingly we're using AI techniques. So this is the work of William Latham and team here at Goldsmiths. It's an evolutionary AI algorithms for creating, you know, these very abstract artistic spaces. And this is some work by a PhD student here, Sokol Morturi, who's using procedural content generation and AI to generate game worlds. So this is an example of a generated game world. I mean, the graphics is fairly ordinary, but it's the layout and the playability is defined by a collaboration between an AI algorithm and a human designer. So again, you have examples of what a world should look like, and the learning algorithm will, you know, learn ways where a designer can put in a little bit of information and generate, you know, a large world or multiple VR or game worlds. Okay, I won't, you know, I'll stop there in terms of content generation and talk about two which are really my area of research. And the first is embodied interaction. So as I said at the beginning of this talk, VR is particularly about how we interact using our whole bodies and how we interact as if we were interacting with the real world. This is, you know, it's about very embodied physical interaction. I should actually give a shout out. This is Christina, PhD student, Christina Dobre. We will see her work later in this talk. But for the moment, she's just looking cool in VR. And these are various examples of Middleton, my own work. The last one's another person's work of use of the body, whether that's, you know, sort of playful, you know, there's a fighting game, there's the next one along is a gestural interface. I was working with archaeologists in Italy, and, you know, how to interact with archaeological reconstructions, and the last one's an example of dance. So we're working with dancers on how to using dance and artistic movement to interact with VR. So one of the great things in VR is that there's a lot of different sensing technology that we can use as input to any AI algorithm. So by definition, all headsets have some kind of head tracking. You know where the head position and rotation of the head is. Oops. You will have hand tracking in most cases. And normally you'll have a microphone, so you can detect the voice. And then the sort of more advanced headsets have, advanced sensors like eye tracking and various forms of physiological sensing, so heart rate, breathing, etc. They can be used to detect sort of emotion. So we've got lots of data coming in, and the question is how to then use that data to really understand what we're doing. And again, we can have lots of examples of human movement that we can feed into our learning algorithm. And sort of this allows us to recognize particular movements and create responses. So again, this is a really hard thing to do. It's understanding what a human is doing when they're moving is equally hard to understanding what the difference is between a cat and a dog in an image. So it's a good example for machine learning. And also, working with, for example, dancers and various movement practitioners, the knowledge is very embodied. So, they're experts in movement, but it's not, a movement and expertise that you can express, explicitly in language, let alone in mathematics, that you probably need for computing. So it's really powerful to be able to allow a dancer or other movement practitioner, could be a yoga teacher, could be many different practitioners, but allow them to express what a movement means in terms of examples of that movement itself. So this is one of the areas we're researching. And I was very inspired actually by a colleague, Rebecca Feebrink, who developed a tool called the Wekinator, which is primarily working with musicians to allow gestural interaction. But her participants really felt that the power of her tool was that it allowed an embodied approach to interaction, to composition, allowing users to generate training examples by actually performing those gestures rather than trying to approach the mapping rationally or mathematically. So they're not trying to break down what they do when they move in terms of mathematical functions. And this allows them much more flexibility, much more an embodied sense of movement, but also much more flexibility and power in terms of what they do. So we're currently working on a project called 4i, the Immersive Interaction Design for Indie Developers with Interactive Machine Learning, which is a collaboration between all these people. The first person is Nicola, who's over there in the crowd. If you've got any questions, please ask Nicola, Clarice, who's here this morning, Carlos, who has escaped away somewhere and is not here today. And then we have Ruth Gibson and Bruno Martelli, Ruth's a choreographer and artist. They're the sort of artistic duo. Rebecca Feebrink, who I just mentioned, and Felix Perry from University of the Arts London. Mike Zhubnitsky, who's here, and then me. So I will describe this project by just playing a video. Fingers crossed, there's no sound. Tara, how do I make sound happen?
Visual scripting tool for designing movement interaction in Unity.
I don't know what happened there.
Interactml is a node-based visual scripting tool for designing movement interaction in Unity. Perform your movement interactions to train Interactml's machine learning system. Then instantly use your movement designs to trigger events in your environment. A tool specifically designed for artists, dance practitioners, as well as game developers. The process is quick and easy, minimal programming experience required. Use any movement input, including virtual reality controllers, hand tracking with the Leap Motion controller, face tracking with AR Foundation, body tracking with the Connect or motion capture system, or any movement sensor in Unity. For more information on our upcoming opportunities, including artist residencies, workshops, game jams, and hackathons, join our mailing list at interactml.com.
Okay, I think for those of us in the room, the audio was really badly out of sync, but anyway, hopefully you got the idea. So InteractML is basically a tool that allows people to design movement interaction with their bodies. And, our hope is that this creates a much more embodied, creative way of thinking about how to interact with VR. And we've just completed a partnership with 3 independent artists that have been working with our tool. We run lots of workshops. We've just completed some residencies with 3 independent artists, well, 4 to a duo, and who've been using our tool to develop their creative work. And fingers crossed in September, we may be able to be in person and see some demos of their work, but we were showing that off at an event anyway. And for those students in the room or online, we're hoping to do a workshop with the 4i team on the 21st of June. Because, this slide is basically talking about the project is not simply about a set of tools. It's not just simply about a technology, but really about a practice of how to use those technologies. And so an equally important part is how we run workshops and how we do the design process as a physical process. So, really not designing on paper, not designing at a screen, but designing by movement. And before the pandemic, we managed to fit in a workshop here at the Tate Modern Museum. We can see here, obviously in the pandemic, we still have been going, but very much with online Zoom and Rec Room based workshops. And you can ask Nicola more if you're interested. Okay, the other thing I want to talk about is virtual humans. So this is something I've been working on for many, many years. And the idea is to have, characters in VR that you can interact with. And now interacting with a character in VR is a really sort of powerful experience. That's virtual Sylvia. It's, unlike a character on screen, you can, you're there with a character that's life size, that's right in front of you, that you can look them in the eyes. And making, so for example, eye contact with a character in VR is very different from, simply having a character look out at the screen with you. It actually feels like eye contact. Body language works. I've had this theory that it's because we're in a shared physical space. You have, you're all in the same 3D space. And our recent research that Carlos, who I mentioned earlier, has been doing has really sort of reinforced that. So it's a very powerful experience. So Sylvia's going to talk a little bit more about some of the work she has done, and that shows the power of virtual humans in medical training. And I'm going to talk a little bit about some of the machine learning methods we've been using. So if you think about how to interact with the character, it's really, the character has to be able to understand what the human being is doing. So, sensing what's going on with the human. As I said earlier, we've got a lot of possible sensors we can use. Character's got to understand what that does, what that human is doing, and create a response, then animate that response, and then the human responds, and it becomes a cycle. Now, the response part is relatively it's not straightforward, but we know how to do that. Like, we can animate characters, you've been doing that for a long time, but understanding what the human does in that's the challenging part, and that's where machine learning comes in. So, I've been working on variations of this kind of approach. You can see here, where we look at capturing, an interaction between 2 people. And the important thing is that this is not simply, recording one person, what one person is doing, but it's recording an interaction. So this is an example of a project we did with University College London on recording a corpus, a data set of conversations between two people. And I'll show you another example of how this is done. So you get this data, you synchronize it together, and you use that to train a machine learning model that goes between what one person is doing, what the real person is doing, and what the character is doing. And then you can use that machine learning model to control virtual characters in their interaction. So I'm going to talk about, we'll show you an example from this particular project. So it's an Innovate UK funded project. I should have said the previous project for is an EPSRC funded project. And this is together a partnership with two games companies, Maze Theory. Russ Harding was the lead on that, and Dream Reality Interactive. Dave Ranyard was the lead on that, and they're both on our jury today, maybe here on the call. Thank you very much, both. And the work was primarily done by Christina Dobre, who I mentioned earlier. And so this was about creating AI characters, and we were applying this to a particular game, which was based on the Peaky Blinders franchise, popular British TV program. So I'll show you what Christina did.
We can understand how humans interact with each other and can say, from their body language, whether they are socially engaged or not. In virtual reality settings, this helps maintain plausibility illusion, but it's difficult to implement, as our judgments are subconscious, so we cannot come up with a set of explicit rules. In this work, we collaborated with two game studios and developed an immersive machine learning pipeline for detecting these kinds of human-defined social attitudes in VR games. First, volunteers took part in a social interaction with a virtual character. Next, an expert annotated the social interaction in the same immersive medium. This data was then used to train a machine learning model. We considered different model configurations, out of which the one that is pre-trained and with a temporal memory performed the best. In terms of input data, we trained it on raw features, such as head position, as well as psychologically based features, such as the distance between the user and the character. The model using the raw features could not generalize to different virtual character positions, whilst derived data performed with 83% accuracy. This work contributes to the field of socially responsive virtual characters, offering a design by example tool for immersive machine learning, to detect abstract social attitudes in VR social interactions, and allowing future VR games to be more engaging, immersive, and inclusive.
Okay, so that's another example of how we can use machine learning to learn interactions between characters. In this case, we weren't having two people in the capture process, but an interaction between a real and a virtual person. And the really important part here is that all of these interactions we've captured are actually immersive. They're in there, then we're capturing their real interaction. And from all, I'm going to hand over to Sylvia in a minute to talk about, how we can use virtual characters and the power of virtual characters in VR. But I just want to make a couple of points here about the use of machine learning. So one is that machine learning, as I've said, can help us deal with what I would call the embodied tacit knowledge and interactions, the stuff we know how to do, the interactions we know we can perform on a daily basis, but we don't necessarily know how to perform. We can't explicitly explain how we do them. Anything from, riding a bicycle to the body language we use in daily conversation. And the second part of this is the importance of making machine learning and AI part of the creative process. So in many ways, AI, these are technologies which are viewed as very obscure and very difficult at the moment. They're things that you have to be this incredible machine learning engineer and have, sort of PhD in maths to understand. But actually, yes, if you're defining the algorithms, then you really need to know this stuff. But machine learning is really about, the most important thing is creating the data set from which things are learned. And, the people whoever knows about the data set, that's the experts in whatever domain. It's not the experts in machine learning. So I think the next sort of frontier is really, how do we make this machine learning process usable to, to ordinary people, domain experts, as we call them, creative people, and usable as a creative tool. And I think that's going to be one of the most important things that comes up in technology generally in the next couple of years, but I think it'll be very important in VR and AR and other immersive media. Okay, I think we're going to hand over to Sylvia in a minute. Does anybody have any questions either here? Yeah, hi.
Yeah, so, you know when you were talking about procedural engines?
Yeah. Yeah. We've got lots of different projects in that area, so I think it varies. So William Latham, the abstract work, that's got a dedicated specialist engine just for that, whereas Sokol Moturi's work is using Unity. We've got another student, Rob Homewood, is also working with Unity to do that. Mostly it would be built into game engines.
Just one more. When you were talking about using AI for movement capture, can you explain a little more about that? Is that about like pose estimation? Is it about between movements? Like what
It's Nicola, do you want to answer? You turned around, or do you want me to answer? Okay, it's so this is the idea is how you interact with a VR environment or game. So so examples, in game-based examples, like people sort of casting spells or performing movements, or it could be, a sporting movement, a fighting game. We've been working with dancers, and the idea there is that well, one project we're working on is kind of a dancer, automatically creating the sort of the scenography, the sounds and lights and the projection. So a dancer can do a movement, it's recognized, and it's the sort of the projections will change based on that. So it's really a way of interacting with the environment. So recognizing what the player is doing and producing some kind of response. So you saw there was an example there of my daughter being a goose, and she was flapping her arms, and then that scared the little dog away. So you've got Orc and got the chicks to come towards her. So it's that kind of interaction. Just replacing, rather than using a controller or buttons to create, to trigger some event, you're actually using your movements.
Yeah, I guess things like I'm just wondering if the AI system might play, because obviously you've got stuff like an engine and stuff like controllers,
So the controllers, that's doing the sensing. So it's really important to have the sensing right, to be able to bring that in. But that gives you just raw data. It will give you where your joints are, for example, what all your bones are doing, the XYZ position of your head. How do you know then from that whether you're waving or punching or flapping your arms? You need some way of recognizing those different movements. It's very complex data. And so there are some cases where you could just put, I don't know how familiar you are with game engine, you can put a collider, you can recognize, oh, my hand is there, but that's very limited. So if you can use AI, then you can use a sort of this machine learning algorithm to take in that data and recognize, oh, it's this kind of flapping movement, oh, it's that kind of. Yeah, it is just a recognition, yeah. Any other questions? Any questions online? Let me try and manage both. Otherwise, I think I'll hand over to Sylvia. Tara, which machine it's this machine. Okay, Sylvia.
Yeah, I just shared my screen. Is it shared?
I can't see anything. Tara, do you want to take it over to your machine? I can see. We can only see a black screen.
Okay, I'm gonna stop sharing and share again. Does it work now? No? Okay, I'm gonna try a different way, which is making this actually just share the higher screen. Does it work now? Oh,
Yes.
well, yeah, it's great, but I can't. Can you still see it?
Yes.
Oh, okay, good. So I can see it, you can see it, which is great. Because I don't really like using Keynote, as in I don't actually present it in presenters mode. I'm just making it massive because as soon as I press play, Keynote takes over my computer and I can't see anything. But now at least I can see you. But basically I don't see anyone now. It's just empty screen in front of me, but at least I can see the chat channel. Okay, so everyone, I don't know who is in the room. I have no idea. I can only see the ones who are online, which is this is a really weird experience.
Sylvia,
We can't see
have
your slides.
our students and a bunch of visitors, various visitors. So say hello.
But can you see my slides? Can you see my?
We can't see your slides yet. We see your desktop.
You see your desktop.
That is not great. Let me see if there's anything else. Okay, can you see my slides now?
No.
No?
No, we can't.
Okay, I don't know what to do. Yeah, it's Teams acting up basically. I'm trying to share my screen, but it just doesn't work. Does it work now? Can you see my PowerPoint presentation at all? No?
No, we see a black screen.
Okay, so I'm going to press play. And then can you see anything now? Still not?
No, we don't.
Okay. Well, I'm not sure. I'm not exactly sure what to do. I can send my slides over, but that's going to take a while.
You want to send it over to me?
Yeah, I think it's, but it's going to take forever to send. I still want to try to figure out how to share my screen. Yeah, because I always share it this way. Nothing bad ever happened to me before. How about now?
No. Oh, yes, we have it.
Okay, I have no idea what happened. Yeah, I just basically went back to the original method and you can see it. Great, let's not mess with it. Okay, so everyone, I'm gonna try to keep it short and leave some time for questions. And so I'm Sylvia Pan. For those of you who haven't met me, I am basically, been working with Marco for many years. And my research has always been about creating believable virtual characters and use them in sort of realistic social interactions, mainly in the medium of VR, either HMD or KFLEX system. And I've been doing that since 2005. And the kind of areas I've been using these are like social anxiety for psychotherapy or medical doctor training, and we're focusing on communication training, where really social interaction is the key. And I have also been working with neuroscientists to try to use VR to understand certain neurological disorders, such as autism. And more recently, Marco and I have been working on this kind of using AI character for immersive games. And as Marco explained, it's really about how do we kind of generate real-time understanding of kind of status of the user using VR equipment as a form of input. So that's the kind of overall of my work. But before going into sort of more details, I just want to go back to the concept of what virtual reality really is, because I feel that this concept has been kind of changing. And as Marco introduced, it is basically about 3 illusions. And we're gonna leave the embodied illusion, which is really, really interesting part of VR, out of the scope of this talk. Because today it's about virtual characters, is about being with somebody else in VR. So I just want to say that VR is about place illusion, which is supported by the VR hardware. It's just sort of psychological experience when whoever puts a VR headset on for the very first time, if it's kind of switched off VR, then you have that wow factor. It's like, wow, this is amazing. I am somewhere else rather than where I actually am, and I have objects and animations played in front of me, and these creatures are actually in front of me rather than being displayed in a 2D screen. And secondly, there's also the plausibility illusion, which is the illusion of events in VR actually real. And these are, and also importantly, these events are related to you personally. And this is actually, I think for most of us here, this is as VR developers or students, this is the area we have to work on. I think it's really, really important to really understand how do we develop and evaluate plausible VR experiences that are actually plausible. And in particular, when it comes to virtual characters, because if you deliver a virtual character that's not plausible, it really breaks the illusion. You're really not using VR to its full potential. And let's see if I can go to the next slide. So what are the difference really between these two illusions? So place illusion, very importantly, is a perceptual illusion. What I mean by that, I mean, look at this image, right? We all know that this piece of thing that is moving around has exactly the same color, but we can't stop ourselves thinking that when it's on the left-hand side, it looks like it's black and blue, but when it moves to the right-hand side, it looks more like yellow and white, okay? And that's basically what VR headsets hardware does to us. So basically, this got to do with how the brain processes visual data, and Marco mentioned the sensory motor contingency. And when all these boxes are ticked, our brain automatically think this virtual digital generated environment is real, and our body would react towards it in a way we can't really stop it. And another sort of feature of place illusion, which is a perceptual illusion, is that when it breaks, sometimes there are some glitches in the VR system, in the VR application. Maybe there are frame rate of all of a sudden drops. Something weird happened, the hardware can switch off and on and blah, blah, blah. But the important thing is when it breaks, the illusion actually comes back quickly. So as soon as maybe there are some frame rate drops, but then when the frame rate comes back to 60 or 90 hertz per second, you have that perceptual illusion back again. But the same thing does not apply on plausibility illusion, because plausibility illusion is a cognitive illusion. It's really to do with how we actually sort of process the world, how we actually think about it. It's really a top-down process, right? So basically, and that is really, really important when it comes to creating believable virtual characters, because when we are interacting with humans in our everyday life, whoever we're interacting with, we automatically have this theory of mind that's operating, and we can try to understand what this person wants from us and what are the objectives, and therefore we can predict and plan how the social interaction will work. And again, although it's cognitive, but we might not be completely conscious about this process. But then when we have virtual characters like this, everybody will have the theory of mind that it is just a machine that is not aware of the physical surroundings and human emotions. And we will not treat this person the same way as we do to our sort of fellow human beings. And another feature about the plausibility illusion is because it's a cognitive illusion, when it breaks, it takes a long time for it to actually come back. So we can't have a virtual character who behaves like a human in a minute, does something amazing, and then the next minute he does some really repetitive movements, which makes us realize this person is actually not real. And then, and maybe the next minute behave really well, really real again, but it might take a bit of time for the user to kind of have the plausibility illusion back up again. Why did I mention this? So basically, these are, in order for the VR to work, to maximize its potential, you really have to have both illusions work. And I just want to also emphasize, in my research, for instance, in the AI character immersive games, I play those VR games, and I don't think I've ever treated any virtual agents as if they were real human, but that's fine because I still have fun. I can still enjoy myself when playing those games. However, when it comes to areas in sort of psychotherapy or training and education, we actually expect people, whoever goes through this process, to be able to apply what they have learned in VR in real life. And this then becomes a problem if you don't have virtual characters that provides a plausibility illusion, because you're not actually providing the kind of psychological journey people would otherwise have with a real human. And obviously, we started doing this, working in this area since 2005. So AI wasn't really that powerful yet. Even now, I'm quite skeptical of how far we can go using, pure AI to create plausibility illusion. But I just want to show you an example of the work we did quite early on in 2005 of how we kind of, make it kind of.
That shirt looks great on you. How much is it?
Can you hear it?
I think it was about £20. It's quite cheap. Thank you very much. Oh, thank you very much.
So this, I don't know if you can hear the audio a little bit or not, because I have a Mac and it doesn't really share sound. But hopefully you get a kind of the feeling of it. And she basically made a compliment of his clothes and he was very happy. And not only he kind of, was replying to her, but also he was swinging his body. He's really in it. So he's enjoying this experience so much that he actually went all the way to the back of the cave wall we have there in order to be closer to this virtual character. But what he didn't know is that we programmed the virtual character to maintain a kind of social distance, interpersonal distance, I should say. That the avatar will always be something like 1.2 meters away from him. So the further he stepped and the further back the avatar actually retrieved. And we also programmed the avatar and also all the other avatars in the scenario to kind of automatically looking at him. There's a gaze model we use, which was, I think, based on Marco's PhD thesis. So there are a few things we did, but I think we were able to really create those kind of experiences that really are plausible. And this is part of an experiment. We're trying to create a kind of pleasant VR experience where I can go to a pub and talk to someone and have a good experience, which will contribute towards a sort of psychotherapy for social anxiety. And that's, again, very early work. And more recently, we've done some other work, but they are actually all using the same kind of principle, right? So basically, our key here is not only that we have to, make sure VR works because we have the hardware and everything. We want to make sure the avatar we use actually are able to maintain the plausibility. And the way we do it, obviously, we use some AI at a sort of background to kind of maintain the body sort of distance and also maintain gaze and everything. But we actually use a way, basically, you can say is fake it until you make it. So we basically use something called human in the loop. So we always have a research assistant sitting in the room, observing the situation, and we develop a fixed sort of control panel with fixed number of sentences, but then the experimenter can observe the situation and trigger whatever they think is most appropriate. And this method is called Wizard of Oz. It's like basically puppetry. And normally, in this case, what was in front of me is one of the experiments we ran. I think this was a 2013-14 experiment we ran, and we had this kind of control panel, and it took about a day to train the experimenter to be able to trigger button really quickly for this scenario. And so we have used virtual human in lots of applications. As Marco said, I want to really here to explain why they're actually useful, not only just in entertainment, but also kind of applications that will really make our real life better. So I just want to very quickly go through some of our work. We've been working with medical doctors on using VR for GP communication training. So VR has been used in medical training a lot, but predominantly is really about surgical skills and everything. But we're actually focusing on sort of how does doctor actually communicate socially with the patients, because that's actually a key area in many aspects of medical training. And I have two examples, but due to time constraint, I'll probably just show the first one, but we also done some work in child safeguarding with VR as well. But today I want to just quickly go through this work we've done about antibiotics prescription. So as you probably are aware that superbugs will become a big problem. If we don't do anything by 2050, superbugs could kill 10 million people per year. And these are basically antibiotic resistant drugs, bugs. And the cause of them, one of the causes of them is basically overprescription of antibiotics. So people would go to their medical doctors and ask for antibiotics, even what they have doesn't really need antibiotics. And then they don't follow through the course, and that basically is one of the biggest contributors for superbugs. So GPs often overprescribe antibiotics because lots of them find it really hard to actually say no when the patients just ask for antibiotics. So in this work, we wanted to know if we can use VR as a training tool for GPs. We also want to know if more experienced GP will be better at saying no to unreasonable antibiotic demands from, in our case, virtual patients. So I'm just actually going to play this video, and hopefully you can hear the sound. If not, let me know.
My mother had exactly the same thing last year.
Right.
It started just like this, a couple of days before. Throat, then a cough. But then she became really very ill with a high temperature fever. I had to take a day off work to take her to the hospital. They gave her antibiotics and she immediately got better. So all she needs is some antibiotics this time.
Okay, I hear what you're saying. But what we often see is with this kind of illness, things settle down by themselves. In the most case, it sounds like you had a bad experience last time, but I think it would be worth trying some simple treatments like painkillers and some fluids and some rest first.
I just asked your daughter if she knows about whether you've been coughing up any phlegm or not. Do you know?
Why do we need to wait until things get worse? Her immune system is not very strong, as you can see. There's no point letting her suffer through this. All we need is some antibiotics.
Sure, no, I understand that, and if the reason I'm asking these extra questions, and I know you're in a hurry, but the reason I'm asking these questions is because actually, very often, a cough is caused by a virus rather than a bacteria.
Even if it is just a virus, isn't it better that we give her some antibiotics to help her immune system?
Well, unfortunately, that's not how antibiotics work. They don't. They don't boost the immune system.
Please, can you give us the antibiotic prescription now? And we will only use it if things get worse.
As I say, I don't think that's necessary right now. Sometimes we can do delayed prescriptions, but you know, I've examined your mum right now and she looks fine to me, and I think this is a virus.
Doctor, maybe you can give us a prescription, but we will only collect it if my mum gets worse.
Okay, it seems like that's something you're both absolutely fixed on having. We can arrange for a prescription that you can pick up tomorrow or the next day if things are getting worse.
Reassuring as I can, I do not think that there
This
is...
is so unfair. It's going to ruin our holiday. I'm going to take this up with the local health authority. I think you are unfairly denying medicine to my mother.
Okay, I appreciate your concern. Thank you for your feedback. I do think that the best medical practice at the moment is to manage this conservatively for now.
My mother worked and paid national health insurance all her life. Now look at what's happening.
Sure, I mean, this has got in no way to do with your mother's health insurance payments. I believe this is the best medical practice at the moment for your mum. I think the use of antibiotics in terms of the risk and the side effects that they can produce, such as resistance to future chest infections or problems with the stomach.
Okay, I'm going to stop here because I don't want to give you more argument that you can use with your GP next time when you want antibiotics. And please don't. It is really a slowly emerging disaster, and we should really all work together on this. So basically, you know, Marco is one before he, you know, present this result, he always just say that, you know, like we have basically 21 medical doctors coming in. And all these doctors, they knew that these are not real patients, these are virtual patients. They also knew that they're being recorded. You know, they're in VR, but they signed a consent form that they'll be video recorded. And they knew this is a clear-cut medical case that you shouldn't be giving antibiotics. But, you know, guess how many actually gave in? Which is in the next slide. If I can go to the next slide. What's going on? Sorry. Some reason it stopped moving. Just going to show it here. So basically, we have 12 experienced GPs and 9 trainee GPs, and none of the trainee GPs managed to say no. They all kind of gave in at some point, and 4 out of the 12 GPs managed to say no. So we were pretty surprised with this this result ourselves as well. And some comments from patients: it felt stressful, as I felt the character were putting me under pressure to make a decision to prescribe. Really useful for testing how you respond to difficult situations. Would be useful to try again using different consultation techniques. So all our GP medical doctor participants really think this is going to be really useful too, and that's why we're still working on it. We did another piece of work, and we're working on a new piece now. So just a quick summary of what the point I'm trying to make today is really, I think VR is a really powerful medium, but what VR provides, the hardware provides, plays illusion, and it's really up to us as VR content creators, to really try to push that plausibility illusion, in particular when it comes to virtual characters. Plausibility illusion, in particular for training and education, is really crucial. And I do think that, especially after Marco's talk of our work in creating, AI-driven characters, how users can, how the machine learning, trained machine learning models can real-time detect level of user engagement. I think this line of work, hopefully in the next 5-10 years, combined with VR, will give us really interesting applications in terms of training, therapy, education, and really immersive, engaging games. And it will fundamentally change many aspects of our quality of life. So that's really, how I got in VR. Is I really believe VR is a way to enhance our real life, and I do think we're getting closer and closer to that goal. And yeah, so here is the lab Marco and I co-lead, the CVR lab, social empathic and embodied VR lab at Goldsmiths. And we also have a Coursera specialization on VR with over 100,000 learners already. And we run this amazing MA, MSc VR and AR master degree with lots of brilliant students you have seen their work. So that's everything from me. So I don't know if Marco is back in the room.